Hello everyone. In the last two videos, we discussed multiples of half and made some observations. So today let's talk about multiples of 1/5 very quickly, how you might talk about it in your class after discussing multiples of half. You might write this fraction 1 over 5 and remind them it looks like 1 over 2, and the denominator in 1 over 2 told us, give us some information. It was to indicate that the unit segment on the number line was cut up into two equal pieces. So you might ask your students, 1 over 5, what might that 5 be telling us? And perhaps they will say that the unit segment must be cut up into 5 equal pieces by length. So then have them draw the number line, a horizontal line, a 0 marked off somewhere, and then ask them where might they want to put their 1, knowing that the segment 0 to 1 must be cut up into 5 equal pieces. So if they're doing it on graph paper, perhaps they'll choose 5 spaces, or you can help them choose 5 spaces or 10 spaces in such a way that the segment can be cut up nicely into 5 equal pieces. So once they draw the number line and they've cut it up and they've marked off all the points, which are and then you can help them with the labeling. Remind them that all of the points, that the first point, well, the unit segment is cut up into 5 equal pieces, and this first point that comes right after, immediately to the right of 0, that is the point whose label is 1 over 5. So once they write that, then you can remind them that every point is then a multiple of 1 over 5. 1 over 5 is called a unit fraction. The unit refers to the 1 in the numerator. You can remind them that 0 by convention is the 0th multiple. We write it as 0 over 5. And the labeling of the rest of the points should be easy. And its label is a fraction symbol with 5 in the denominator. And the numerator, as you can see, is just like counting in whole numbers, 0, 1, 2, 3, 4, and so on. The numerator, for instance, if you look at 6/5, that's telling us it's the 6th multiple of 1/5. 1, 2, 3, 4, 5, 6, 6th multiple, and so on. So remind them of all of those things that we already discussed for 1/2. Same thing for 1/5. And then we can make some observations just like we did for the multiples of half. The first observations your student would be able to see is that 5, since you started out with cutting the unit segment into 5 equal pieces, and each piece is length is a fifth, and I suppose you should remind them that this point is a fifth, is 1/5, and its distance from 0 is 1/5. This point is 2/5, and its distance from 0 is 2/5. Once you make that observation and you tell them that each piece is of length a fifth, then they can see 5 of those 1/5 make up a 1. This segment is of length 1, and it's made up of a fifth of these shorter segments, each one of length 1. So length 1/5. So 1 equals 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, just like this. So 5 fifths, 5 1/5ths make up a 1. That can be their first observation. And for the second observation, you can pick 8/5, or you can pick as many of these as you can, and I'm just doing it for 8/5. You would want them to see that just like the number 8 is made up of 8 equals 1 plus 1 plus 1 plus, you add 8 number of 1s and you get 8. Similarly, you want them to see 8/5 is made up of adding 8 of those 1/5. Where do they see that on the number line? Let's look at this 8/5, this segment. The segment that goes from 0 to 8/5 is a long segment that's made up, whose length is 8 over 5, and it's made up of 8 shorter segments, and each of the shorter segment is of length 1/5. That's where geometrically they're getting this equation, that 8/5 can be decomposed into 8 number of 1/5, just like 8 can be decomposed into 8 number of 1s added together. So that's the second observation. And finally, this last observation has to do with equivalent fractions. Once again, we don't use that word at this time. We'll use it in a future video. Right now, just from the observations, they're developing this intuitive feeling that certain points can have two labels, and when they and so on. And in the future, we will say two fractions are equivalent if they're the same point. So right away from this picture, they're going to see 2 and 10 over 5 are equivalent fractions. They won't use the word, but they will see that 2 is this point, 10 over 5 is this point. So they will be able to write 2 equals 10 over 5. And similarly for all of these. Same thing, similar way that I discussed for multiples of half. And then they should be able to see a pattern. You can help them, or you can work with them, engage them in a dialogue, and ask them where this 15 is coming from. And they should be able to figure out that 15 is 3 times 5, and they should be able to figure that out from the picture. How is that? The 3 refers to this big long segment from 0 to 3. And 3 equals 15 over 5. So this 15 over 5, how do we get the 15 up there? We're saying this point is the 15th multiple of 1/5. How is that? Well, this segment is divided up into 5 equal pieces. This segment is divided up into 5 equal pieces, and this one is also divided up into 5 equal pieces. There they can see 5 times 3, that it's that 15. So that's how they can see it. Once they see that pattern, again for fifth and higher grades, it would be good to summarize it and say, well, if we can also write it as m equals 5 times m over 5, where m is any whole number. Be sure to, again, when you use a letter, to say what m stands for, and indicate to them that this equation now contains all of the information that's written here, and for everything else that you did not write in there either. So if m equals 3, it's exactly this equation. If m equals 2, it's exactly this equation is exactly same as that one, and so on. So that's multiples of 1/5, and you can do more of the multiples of unit fractions as needed for your class, until they understand that fractions are really a collection of all of this unit fraction and all of its multiples. And we'll summarize that in another video.